A little recap from yesterday. If you're solving a radical equation, which means there's a variable inside of a square root, you have to get that square root by itself, and then if you square both sides, it would get rid of the square root. But we also, I should put it as a third step, because it's possible to get something that is equal, and I think I showed you these numbers yesterday. It's possible to get something that's equal after squaring, but your original numbers weren't equal. Sometimes we're going to get answers that are not actually answers. They're called extraneous roots. So a thing with square root equations, we always will have to verify. Even if the question doesn't say verify, you have to know that this is the type of question you always have to verify. So in B, here's my term with the square root. We need to isolate that. So first of all, the minus 7 and the 13, those are like terms. I could add 7 to the other side, and I would get 20. Now we've isolated the square root. You could already go to step 2 here and square both sides. Or you could do a little bit of more simplification if you wanted to. Can you see that you could divide both sides by 2? The nice thing about simplifying and getting just the square root by itself is you're going to deal with smaller numbers. So technically, you could square root both sides. I would prefer on this one to divide both sides by 2. And then square. So now if I square this side and I square this side, I'm going to get 100 equals just x plus 1. Subtract 1 on both sides, and I get x equals 99. How do we verify? We draw a line. We set up our left side and our right side. We go to our original equation. The left side was 13. The right side was 2 square root of, and we plug in our 99, plus 1, minus 7, and we check, are they identical? So this will be 2 times the square root of 100, minus 7, this is 2 times 10, minus 7 is 13. So we know that our answer of x equals 99 is correct. All right, circle questions 4, 5, and 6.